So conservative plate boundary is where you have two plates sliding next to each other. Sometimes this can be in the opposite direction. Sometimes the plates are sliding in the same direction, but at different speeds. But where we've got two plates sliding next to each other, there's no magma involved at all. So we don't have volcanoes at conservative plate boundaries at all. What we do have is earthquakes. So as these two plates are sliding next to each other, they work in a stick-slip process. The plates quite often get stuck as they try to slide next to each other. And so we have this phase of where they are stuck, the stick phase. And this can be for several hundred years that these plates are trying to move past each other. So you can imagine how much pressure builds up over that period as the two plates try to move past each other. Eventually, they do manage to slip. They do manage to move past each other. And in the slip phase, all of that energy that has built up, all of that pressure that has built up over those several hundred years sometimes is released as a series of seismic waves. And that's our earthquake. The classic example of a conservative plate boundary is the San Andreas Fault in California in America. It's exactly the same process at a destructive plate boundary and at a collision plate boundary in terms of earthquake formation. The plates sliding next to each other or past each other get stuck, build up pressure, and then when that pressure is released as they slip past each other, that's our earthquake.